Yeah, hi everyone. This is a really important video about some special right triangles and their trigonometric ratios. This is something you're going to have to know and to memorize. Uh, Two very special right angle triangles you need to get familiar with. First one is the 30-60. Here we have an equilateral triangle. All sides the same, all the angles are 60 degrees. You split it in half, perpendicular bisector there, and you get a triangle that has 60 degrees there and 30 degrees in that angle and 90 in the other one. Adds up to 180, of course. Okay, imagine that your original triangle had sides of 2. So that side's still 2. The one at the bottom is now 1 because you've cut it in half, perpendicular bisector. If we use Pythagoras' theorem, we get the other side is root 3. Using this information, we can learn all about the trigonometric ratios, sine, cos, and tan, of these angles 30 degrees and 60 degrees. Okay, let's have a look. Sine 30 is a half. That's because there's 30. It's opposite over hypotenuse, 1 over 2. Cos 30, adjacent over hypotenuse, root 3 over 2. Tan 30, opposite over adjacent, 1 over root 3, or sometimes we write it root 3 over 3, and we rationalize the denominator. I tend to remember 1 over root 3. Okay, we'll do the same thing for 60 degrees. Sine 60, opposite over adjacent. There's 60, opposite is root 3, not adjacent, hypotenuse. Sine 60 is root 3 over 2, opposite over hypotenuse. Cos 60, adjacent over hypotenuse. Tan 60, root 3, opposite over 1, adjacent, which is root 3. Okay, you'll notice a couple of things here. Sine 30 is the same as cos 60. Cos 30 is the same as sine 60. That's always going to be the case. If the angle of the sine and the angle of the cos add up to 90, then their values will be the same. And tan is opposite over adjacent. It's also sine divided by cos. A half divided by root 3 over 2. The 2's cancel out, you get 1 over root 3. Same thing over here. Okay, let's look at the 45-degree triangle. Real important triangle you come across a lot. There's a square. You cut the square in half, but not down the middle. You can make it a triangle along the diagonal, and you get a 45-degree triangle, right triangle. Okay, imagine that your original square was 1 by 1, so this is still 1 by 1. Using Pythagoras we get the root 2. I forgot to tell you before, it doesn't matter if our triangle was bigger than 2, or here our triangle is bigger than 1, the sides of our triangle is bigger than 1, because the ratios will take care of themselves. So you have different triangles that are different sizes, but if they have the same angles they'll have the same trig ratios. Sine 45 is opposite over hypotenuse, so that's 1 over root 2. We'll look at this 45 degree here, 1 over root 2. If you want to rationalize the denominator, that's root 2 over 2. Cos, adjacent over hypotenuse, so 1 over root 2 again, and tan is 1 over 1, opposite over adjacent, or if you really want, it's sine divided by cos. 1 over root 2 divided by 1 over root 2 equals 1. So that's the summary, and these values you have to memorize. Okay, it's going to be really helpful for other work you do. It's going to save you time on exams. You need to memorize these values. I find it easy to remember the triangles and to work out the values. I already know what sine, cos, and tan is because I've been doing it for ages. I find it hard to remember these fractions, but I can remember the triangle and say, okay, cos 60 is adjacent over hypotenuse, so that's 1 over 2. Okay, easy to remember. I want to show you quickly an alternative method. Remember it in a table. You'll see this. The sine theta, as the angle goes from 0 to 90, the values go up from 0 to 1. Cos theta, it's the opposite. The values of the ratio cos goes from 1 down to 0. And you'll see the numbers are the same. Okay, and remember tan is just sine divided by cos, so you can remember those ones pretty easy. Okay, so same numbers, sine goes up, cos goes down. If that's hard to remember, there's an additional step you can take. We can rationalize the denominator. If you just look at sine there, what do you notice? Denominator, 2, 2, 2. Hey, what's 1? That's the square root of 1. You know, 1, that's 2 over 2. 2 is the square root of 4. So that's the square root of 4 over 2. So if you can't remember how it works, you can remember 1, 2, 3, 4, can't you? So 1, 2, 3, 4, square roots of them over 2 gives you that. Probably not the best way to remember it in a table during an exam, but it's a good little method that backs up everything. Okay, so then the values of sine, cos and tan for 0, 30, 45, 60 and 90. The next step you'll have to do, this is just a quick preview, is angles bigger than 90, and you can see when you go around a circle with other angles you can do the same thing. But if you look at these numbers here, they remind you of something. Yeah, and look, they're the same values over here. Maybe they're negative, but always the same values. So that's something you'll come across a bit later. We can also represent it on a graph like this, and you can see that the values of sine here, the purple one, start at 0 and go up to 1 at 90, and there's the different things, different values in between, and they're repeated over here and they're repeated over here, so you can see how that's going to work. But that's for later on as well. That's just a little preview. This is what I really want you to remember. Okay, you have to remember these values here. You can remember them in a table, but I think it's easy to remember the triangles and work them out. Okay, I hope that was helpful, and good luck remembering all of that.